How to incorporate risk in capital budgeting. So in this lesson, we will go through the introduction. We will see investment decisions under certainty is risk-free. Under certainty means under certain conditions are risk-free. In most cases, our estimation of projects is not risk-free because that is the reality. Fact is there exists risk even in capital budgeting. Hence, we need to adjust risk in capital budgeting decisions. So this is what exactly is the reality, and that is where we have to incorporate risk into capital budgeting. So if you take the first point, investment decisions under certainty is risk-free. So when the financial manager makes investment decisions under conditions where there is a condition of certainty, the investments are considered risk-free. This is the fundamental assumption of capital budgeting techniques, where the assumption implies that for net present value, whenever there is a positive value, it can be stated that the project proposals remain an accepted proposal. This is under condition of certainty, when everything is certain. But in reality, that is not always true. So that is our second point. In most cases, our estimation of projects is not risk-free. So due to the availability of better technology on a day-to-day basis and due to availability of newer and better materials, that is raw materials, our estimates on the project can get invalidated, and any calculations made on this basis, for example, NPV calculations, may remain unacceptable. In short, there exists risk in even capital budgeting calculations. So that is true fact. There exists risk even in capital budgeting. So we can say some risk is always associated with a project. So there exist cash variations, and this would be reflected in every project considered in capital budgeting also. Hence, we need to do what? We need to adjust risk in capital budgeting decisions. Hence, we need to basically adjust the risk in capital budgeting decisions. There are two methods it is done or taken care of, and that is what we see next. So adjusting risk in capital budgeting, it is done by certainty equivalent approach, and the other one is risk adjusted discount rate. These are the two methods in which we actually adjust risk in capital budgeting. So let us first see what is certainty equivalent approach. So in this approach, there are two types of cash flow. One is expected cash flow, which is uncertain, and the other one is certain cash flow, which is guaranteed to return amount on an yearly basis. So the first step is in finding out certainty equivalent coefficient, which can be found out by two methods. So the first method of finding the coefficient, certainty equivalent coefficient, is by dividing certain cash flow by risky cash flow. That is one method of finding it out. There is another method of finding certainty equivalent coefficient, and that is given risk adjusted rate of return and risk free rate. If these two risks are given, risk premium is found out by the difference between risk adjusted rate of return and risk free rate. So once we get the risk premium, we actually add 1 to the risk premium and we take the inverse, which would be the coefficient of certainty equivalent. So one, that is alpha. So once alpha is found out, the net present value is obtained by the equation NPV is equal to C0 plus etc. alpha into Cn by 1 plus I the whole power n. So that is the equation to find out NPV. So only thing is we have to find out alpha by any of these methods and then multiply it with the cash flow for a particular year, which is n is the number of year, and which we divide by 1 plus I, which is the interest rate or the return which we actually have. So that is one method of finding it out, the NPV. We'll go into some calculations in this regard. We know that alpha should be, or alpha or the coefficient of certainty equivalent should be any value between 0 and 1. So we'll take an example. We say that the expected cash flow is 10 lakh 8,000 rupees and the risk adjusted rate of return is 12% and risk free rate is 3%. So we calculate risk premium, which is 12 minus 3, which is 9%. So what is alpha? Alpha by our equation, it is inverse of 1.09 because we add 1 to 9%, which is 1.09. We take the inverse and we get alpha or the coefficient of certainty equivalent. That would mean certain cash flow or guaranteed cash flow given the expected cash flow. Expected cash flow is given as 10 lakh 8,000. So given expected cash flow, we find out the guaranteed cash flow as 10 lakh 8,000 divided by 1.09, which is the alpha. Because we know alpha is certain cash flow divided by risky cash flow. So the guaranteed cash flow, we obtain it as 9,24,770. So that is one illustration of the certainty equivalent approach. Next, we take a look at the last approach, which we actually see in this part, which is risk-adjusted discount rate. So in risk-adjusted discount rate, risk is accounted for by adjusting the denominator of NPV equation so that greater the risk. So here, what is the risk? Which is adjusted with the interest rate, which is the rate of return. So we adjust I. If I goes up, if the risk is higher, I goes up. And if the greater the risk, higher will be the discount rate. 1 plus I the whole power n will be higher and lower will be the net present value. So that is risk adjusted discount rate. And by that we conclude how to incorporate risk into capital budgeting part 1. Thank you.